Hello everyone, good evening. So here we shall solve the exercise 1 on quadrilaterals. So in the very first question, it is told that the angles of quadrilateral are in the ratio 3:5:9:30. And find all the angles of the quadrilateral. So as you know, there is a rule that the sum of all the interior angles of a quadrilateral, sum of all the interior angles of a quadrilateral is equal to 360 degrees. So now here it is told the angles are in the ratio 3:5:9:13. And so let the angles be, so we can say let the angles be 3x degree, 5x degree, 9x degree, and 13x degree respectively. Now, therefore, we can say that their sum is equal to 360. So 3x plus 5x plus 9x plus 13x, that should be equal to 360. So 3x plus 5x, that is 8x plus 9x, that is 17x. 17x plus 13, that is equal to 30x. So we can say 9 plus 5, 14, 14 plus 3, 17, 17 plus 3 is 20, 20 plus 10 is 30. So 30x equals to 360. Therefore, x will be equal to 360 divided by 30. So 12 3 are 36. So it means x equals to 12. So therefore, I can say the angles are 12 into 3, 3x. So 12 3 that is 36 degree. And 12 5s are 60 degree. 12 9s are 108 degree. And 12 13s are 12 3s are 36. 12 into 13, so I can say 12 3s are 36, 12 1 are 12, 156. So 156 degree. So the required angles are these. So this is the answer. The question number 2, it is told if the diagonals of a parallelogram are equal, then show that it is a rectangle. If we have a parallelogram ABCD, those diagonals are AC and BD, and they are equal, then we have to show that it is a rectangle. So it is given that you can say in parallelogram ABCD, the diagonals AC and BD are equal. AC and BD are equal. Then we have to prove that ABCD is a rectangle. So how to show that it is a rectangle? Simply we have to show that each of the angles is a right angle. Since we can say that a rectangle is a parallelogram whose each angle is a right angle. The diagonals are equal. So we have to prove. In the proof, we can say that We will take triangle ABD, and BAC. So in triangle ABD and triangle BAC, you can see that AC equals to BD, which is given, and you can see that AB is the common side. AB is the common side, and AD is equal to BC. AD equals to BC since the opposite sides of a parallelogram are equal. Since the opposite sides of a parallelogram are equal. Opposite sides of a parallelogram are equal. So therefore, we can say that triangle ABD is congruent to triangle BAC by SSS rule, by side rule of congruency. SSS rule of congruency. So you can say that angle BAT, that is equal to angle BAD is equal to angle ABC, CPCT. So, and also we can see that also angle BAD plus angle ABC, that is equal to 180. Since AD parallel to BC and AB is the transversal, and since they are co-interior angles, these co-interior angles are equal. Co-interior angles are equal. So now these two angles are equal. So therefore I can say therefore angle BAD, that is equal to angle ABC, that is equal to 180 degree divided by 2, that is equal to 90 degree. So hence we can see that these two angles are right angles. So therefore we can see that in parallelogram ABCD, angle A, that is equal to angle B, that is equal to 90 degree. So we can also say that angle B equals to 90 degree. So we can say that now angle A will be equal to angle C and angle B will be equal to angle D also. Also we can say angle A equal to angle C and angle B equal to angle D. Since why? Since in a parallelogram the opposite angles are equal. In a parallelogram the opposite angles are equal. So we can say that E equals to angle D. So we can say that all the angles, angle A equal to angle B equal to angle C equal to angle D equals to 90 degree. So hence we can say hence ABCD is a rectangle. ABCD is a rectangle since it is a parallelogram with all angles is a right angle. So hence proved. Here in question number 3 it is told show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. So if you take this is ABCD, So we have to show that ABCD is a rhombus if they bisect each other at the point. नहीं सर रिकॉर्डिंग अच्छा रिकॉर्डिंग उसके बाद इसका ले So it is given that ABCD is a quadrilateral. ABCD is a quadrilateral in which the diagonals AC and BD bisect each other at the point here, or that is, we can say that is OA equal to OC, and OB equal to OD, OB equals to OD, OB equals to OD. Then we have to prove that ABCD is a rhombus. ABCD is a rhombus. So we have to prove it. So the proof is that so we'll say that in triangle OAD and triangle OCB, angle AOD, that is equal to angle BOC, since they are vertically opposite angles. Since vertically opposite angles are equal, and this OB equals to OD and OA equals to OC. It is given. So therefore we can say that triangle OAD is congruent to triangle OCB. Triangle OAD equals to is congruent to triangle OCB by SAS rule of congruency. The SAS rule of congruency. Therefore, we can say that AD equals to BC. AD equals to BC and angle OAD equals to angle OCB. The reason is CPG. So therefore we can say that AD parallel to BC also. Since why? Since alternate in triangles are equal, means OAD is equal to OCB, means that since angle, you can say CAD, that is equal to angle CAD, that is equal to angle ACB. So alternate interior angles are equal. Alternate interior angles are equal. So hence two opposite sides are parallel and they are equal also. Hence I can say that ABCD is a parallelogram. So therefore I can say that ABCD is a parallelogram. Parallelogram. And also, yes, so it is a parallelogram. Now, and also we can say that, angle Now, these two angles we have proved that is same. These two sides also will be same. In these two triangles, these two sides are equal, and this is the common side.